Hey guys, it's an exciting day today because it's a lab day, and I'm going to be walking through this with you together. And what I would like you to do is go to Google Classroom and find the lab document that we'll be working with today. It's called The Formation and Decomposition of Zinc Iodide, and I have a special 2020 distance version just for you. So take a minute to do that. Pause this video if you need to while you find it, and then we'll get going on what we're going to do today. So our question that we're researching is, how can a compound be synthesized or put together from its elements and then decomposed back into its original elements? In a nutshell, what we are doing is taking one element, say zinc, and we are attaching onto it two iodines. That's the synthesis part of putting together zinc iodide. And then we're going to decompose it or pull our parts back apart. That's what we're going to be doing in this lab. Okay, let's get started with what we're going to do. So first thing is some safety stuff. I would like you to click on this link. It will take you to the safety data sheet for iodine. The other element that we're working with today is zinc, and we've worked with that one before. We know it's a fairly safe metal, but take a look at the safety data sheet for iodine, and I would like you to type in here safety concerns and personal protective equipment and first aid measures. If during this lab activity I get some on my hands or in my eyes, what should I do? Please record those things so that I'm well informed. Okay. Go ahead and pause the video and do that. Okay, now we're going to get into the procedure for this lab activity. So follow along with me. It says I need a test tube and a 50 milliliter beaker. Check, check. Add about 1 gram of zinc powder and 10 milliliters of distilled water to the test tube. Let me get those ready. All right, I'm going to measure out the zinc powder. Here we go. I'm looking for 1 gram. I'm going to hit the tare button. Ooh, that was a little too much. Let me take some off. Sprinkle a little bit more back on. I'm going to go with 0.92 grams. It said about, so I think that's going to be good. All right. My 10 mils of water and my zinc powder are going into the test tube. Oh boy. I just dumped some of it on the table. Let me get a little more. Okay, I've got those together in here now. And number 3 says, obtain about 1 gram of iodine from the fume hood. Carefully add the iodine to the test tube. Well, let me get the iodine ready. Okay, here's the iodine. I'm going to put about 1 gram of that in here. You know from the safety data sheet, I don't want to mess with this stuff too much. 0.61. Ooh, I can smell it. I don't want to breathe in too many of those fumes. All right, I'm going to call that good. Just short of 1 gram. Now that iodine is going to go into my test tube. Ooh, something started to happen. So when I dumped that in, it started to bubble and fizz, and the test tube started getting warm when I did that. And whenever I stir it, I hear more fizzing in there. So I'm noticing for number 3, it said record my observations when I dumped it in. And number 4 is saying vigorously stir it and also record observations. So down below, there's a space to do some of that. Step number 3, when I dumped them together, I heard some bubbling and fizzing, and it got warm. And then when I stirred it, I had more bubbling and fizzing, and it got warm. Move that over there to see it a little better. Okay. Number 5 says allow the mixture to settle. If the test tube is hot, use a clamp to pick it up and pour it into the small beaker. Well, I don't think it's so hot that I can't pick it up, but I am going to dump it into this small beaker like so. Get this out of the way. And also add distilled water to make the total volume about 25 milliliters. So these lines on the beakers aren't accurate for measuring, but it just says approximately 25 milliliters. So I'm just going to add some more distilled water like this. So that was number 6. Number 7 says obtain a 9-volt battery. Bing. With wire leads. Ta-da! And attach the copper wires to the leads from the battery. So I'm going to put the black one on negative, and I'm going to put the red one on the positive side of the battery. Not that that makes a big difference, but that's traditionally how the colors are done, just like that. And then I'm going to attach these wires to some copper pieces. Okay, I've got my wires connected to my copper pieces, and just like the picture over on the right side, I'm going to insert those into my solution. I don't want the copper wires to touch in there. I just want them to enter in. And right away I'm noticing something starting to change. Let's see if we can get a good view of this. Near the black negative side of the battery, the copper is changing color. And over on the red, well, I said that backwards, black negative, red positive side, right around my copper wire, it's turning kind of yellowish, kind of that traditional iodine color. And the copper is also changing. It says, observe what takes place for number 8 and record your observations. Number 9 says, after 2 minutes, remove the wires from the solution and examine the wires. Again, record your observations. Well, I think enough time has gone by that we can even examine these now. I'm starting to notice some things. Let's take a look at these wires. They started out copper colored, and now we've got some color change happening. I'm going to get a white piece of paper here to make it a little bit easier to see perhaps. On the black negative side, I've got this grayish stuff that is on the wire. Okay, this is the black negative one. There's grayish stuff on there. And maybe I should let this one go a little bit longer, but on the red positive side, I've also got some coloration. I'm going to leave that in there for a little bit longer, and we'll come back to it in a minute. Okay, I let those in there a little longer, and now let's take a look and see what they look like now. First, the black one that had been connected to the negative side of the battery. It's got this thicker now clump of gray stuff on it. And the other one has, I want to focus on, there's these blackish colored spots. So darkish coloring, darker than the gray covering from the other wire. All right, so it says for number 10, you may dump your liquid down the drain. I'll do that at the end here. Dump the leftover iodine and zinc into the waste container. I'll do that too. Then 11 says use sandpaper to clean off the copper wires and put back into the container. I'm just going to wipe off this wire, and I've got some sandpaper here. And I'll do the same with this one, wipe this one off. And now we're going to talk about what in the world just happened with these wires. All right, now's the exciting part for me as a chemistry guy, and that is to answer the question, what in the heck was going on that we saw those bubbles, that it got real hot, that we saw the change in colors? What was going on? In other words, taking a look at the macroscopic big stuff that we could see, what was happening on the little itty-bitty submicroscopic scale with the atoms? Well, that's what I'd like to explain next. And understanding this will help you to answer some of the questions at the end of your lab. Ready? Let's do this. So I've got here some models of some atoms. I've got zinc. Zinc has 2 valence electrons. That's what these 2 dots are. And I've got iodine. Iodine has 7 valence electrons. So that's what I have here. And when you put zinc and iodine together, This one valence electron is going to be attracted by the iodine. Iodine is electronegative. That means it likes to take electrons from others. And this one is going to go over here. And when that happens, each iodine gets the last valence electron it wants, so it has a full outer level. And so now each iodine is negative. And this zinc over here, who gave up 2 negative electrons, has a charge of +2. We could say that zinc is a cation, and iodine, or now iodide, is an anion. So when you have a bunch of these in a beaker like we have over here, let's talk about what's going on in here with these atoms. And that is this. Each zinc is going to attach onto 2 iodines because the positive zincs are going to be attracted by the negative, attracted to the negative iodides. And as soon as all the iodine gets used up, the reaction stops. While it's happening, that's when we see the bubbling happening, and we feel the heat being given off because it's an exothermic process. Then once all the iodine gets used up, the reaction stops. And so this is what we have in our beaker now, the zinc iodide, and probably some leftover zinc that didn't get used up. And so that was the first part. That was the synthesis or putting together of our compound. Then we used our 9-volt battery, put in some wires, and we split it back apart. Let's take a look at what that looks like. So I'm going to put my red wire coming out of the positive side, going down into my beaker here. And I'm going to put a black wire coming off the negative side, like this. There we go. And now keep in mind this one's negative. This one's positive, and you should be able to predict what happens when we use electricity to split something. We call it electrolysis. Which one of these, the zinc or the iodine, is going to stick onto the negative side, keeping in mind that opposites attract? Well, the negative side of the battery is going to attract the positive cation. That was the zinc. So all these zincs are like, I'm more attracted to this wire than I am to you, iodine. We're breaking up. And iodine's like, fine, if you're going to break up with me, then you can just believe that I'm breaking up with you. And I'm going over here to this positive thing. I'm done with you. And zinc's like, okay. And so we had those color changes on the copper wire. It was just each element getting attracted to the wire because they had opposite charges. Whoa, pretty cool, huh? So we put together zinc iodide, then we used some electricity to split it back apart, and there we have it. I think you probably now know what you need to know to answer the questions on your lab. I'm just going to skim these real quick. I think so. I think you're ready to go. Great job, guys, and we'll see you later.